So now for this video, we're actually going to apply these inverse trig ratios to find angles. So here in problem 1, let angle A, angle B, and angle C be acute angles. Use a calculator to approximate the measures of these three angles to the nearest tenth of a degree. So I have that tangent of A is equal to 3/5. Well, I know I can take the inverse tangent on both sides. And so when I have tangent, inverse, and tangent, those cancel each other out. So I just have measure of angle A is equal to the inverse tangent of 3/5. And now I need to go over to Desmos to actually find out what this is. So I'm going to go Desmos. First things first, super important, you need to hit this kind of wrench over here, and you need to change this to degrees. If you don't have it in degrees, it's going to give you a wrong answer. And now to get the inverse tangent, what you're going to do is you're going to click on this show keypad here. You're going to go to functions, and they are all right here. So I'm going to click on tangent inverse, and then type in 3/5. So I'm just going to do 3, the slash button, which is the same key as your question mark, and 5. And I see that I get 30.96375, and so on. I want to round this to the nearest tenth, so I look at 6. I see that means I need to raise my 9 up 1, so this is going to become 31 degrees. So let's try another example. So now I have sine of B is equal to 13/17. So to find what my measure of angle B is, I need to take the inverse sine on both sides. So I get that the measure of angle B is equal to inverse sine of 13/17. So going back over to Desmos, click on functions. I'm going to find sine inverse, and that is this one. And this was 13/17. And so I get 49.9 when I round to the nearest tenth. Okay, go ahead and pause the video. I want you to try and find C. So the answer you should have gotten was 81.4 degrees. Okay, now let's go into some actual problems where we're trying to find an angle. So here I have a right triangle, and I see I'm given these two sides. So my first step is to figure out what type of sides those are, if they're opposite, hypotenuse, or adjacent. I first like to go ahead and label my hypotenuse, so that's going to be my 8 because it's the side that's opposite of my right angle. And then the 6, I see that's opposite of my missing angle, and so that means it's my opposite side. So thinking of SOHCAHTOA, that means that this one's so. It's opposite in hypotenuse. So that means that the sine of x is equal to my opposite, which is 6, over my hypotenuse, which is 8. And now I'm going to do just exactly like we did in those previous examples. I'm going to take the inverse sine on both sides. So that x is equal to sine inverse of 6/8. So heading over to Desmos, I'm going to click on sine inverse of 6/8. And rounding to the nearest tenth, that means I get 48.6. So my missing angle here is 48.6 degrees. Okay, let's try another one. So this one I have first my hypotenuse. I see that is this 5.75. And then I see this side here, this 5, it's right next to my missing angle, and it's not the hypotenuse, so that means that this is my adjacent side. So the trig ratio that has adjacent hypotenuse, that is my cosine, the COB part of SOHCAHTOA. So that means that cosine of my missing angle x is equal to my adjacent side, which is 5, over my hypotenuse, which is 5.75. And then now I'm going to take the cosine inverse on both sides. And again, this allows me to get x by itself. So those cancel each other out. And so I have x is equal to cosine inverse of 5 over 5.75. So go to functions, click on cosine inverse, and I'm going to type in 5 divided by 5.75. And rounding to the nearest tenth, I see that my missing angle is 29.6 degrees. Okay, go ahead and pause the video. I want you to try and do this last one on your own. So the answer you should have gotten here was 32.5 degrees.